Assalamualaikum and hi. So now we are going to look at subtopic 4.7 from chapter 4, motion of charged particles in magnetic field and electric field. So we are going to look at what is going to happen to the charged particle when it moves in the magnetic and also electric field. In our previous subtopic, we have looked at what happened to the charge. Let's say you have a positive charge that is moving with a velocity v, enters a uniform magnetic field. Contoh, kita ada magnetic field dekat sini. So when your charged particles enter with a velocity v dan ada b dekat sini, apa yang akan jadi is that your charge when it enters, it is going to make a circular motion, di mana kita samakan magnetic force dengan circular motion force, centripetal force kita lah. Okay, so kita tahu bila charged particles moving with a certain speed v enters a uniform magnetic field, dia akan buat circular motion. Tapi dalam subtopik ni kita nak tengok what is going to happen kepada charge yang bergerak dengan speed v masuk ke dalam kawasan yang ada magnetic field dan juga penambahan iaitu electric field. That is an overview for this subtopic. So we have two learning objectives here. The first one is to explain the motion of the moving charged particles in magnetic field and electric field for velocity v, magnetic field b and also electric field e perpendicular to each other. Maksudnya kita punya velocity perpendicular to the b, perpendicular to the electric field. They are all perpendicular to each other. Contoh, satu along y axis, another one along x axis, another one along z axis. Okay. And then next we have use velocity selector. V is equals to E over B in a velocity selector. Alright, sebelum kita tengok kepada what is going to happen to the motion of the charge, we're going to understand first what is velocity selector. Velocity selector, okay, velocity selector is a device that has been made up of parallel plates which gives you an electric field. Kita akan produce electric field dan juga these parallel plates are in uniform magnetic field. So kita akan ada B dan juga E dekat sini. Alright. So now consider a positively charged particle with mass m, charge q and velocity v. So this is your charged particles, ada mass, ada charge dan juga ada velocity, enters a region of space where the electric and magnetic field are perpendicular to the particle's velocity and to each other as shown in the figure above. So kita ada electric field. Kalau kamu tengok, direction of electric fields adalah downwards, which is along y component kita. This is direction of electric field. B kita pula dekat sini cross. So kalau dia cross, dia adalah into the page. So dia punya direction dekat sini adalah along z direction. Okay, so kita ada into the page dekat sini. Ini z saya. And then kita ada one more iaitu kita punya velocity, iaitu velocity tengah moving to the right, iaitu ke kanan sini. Okay, this is my x. Ini kena 90 darjah. Ini pun kena 90 darjah dekat sini. Alright. So dia melibatkan paksi y, x dan juga z dekat sini. Okay, so your electric field is along y axis, your magnetic field is along z axis and also your velocity is along x axis. So they are perpendicular to each other dekat sini. Okay, the charged particles will experience the electric force Fe is downwards with magnitude of QE and magnetic force Fb is upwards with magnitude of QVB. So what is going to happen adalah kita nak tengok, remembering your chapter 1 knowledge, when you have charged particles entering uniform electric field, kita ada electric field di mana direction of electric field adalah ke bawah sebab it travels from positive plate to negative plate. So charged particles yang masuk ini bersifat positif. So this positive charge is going to be repelled by the positive plate and attracted by the negative plate. So dia akan ada electrostatic force ke bawah. So the electrostatic force acting on the charged particles adalah pointed downwards. So this is the electrostatic force. Ini charge kamu. And then using your right hand palm rule, using that understanding, you have you have magnetic field into the page, you have velocity to the right. So menggunakan your fingers pointing to the right in the direction of the velocity, and then you have your palm pointing in the direction of into the page representing your magnetic field. Kamu akan dapat thumb kamu ini pointing upwards, which gives you the direction of magnetic field. So this charge, will give you the direction of magnetic force. Okay? So you are going to have magnetic force ke atas pula. I repeat myself. Kita ada positive charge, dia masuk ke dalam parallel plate. Okay, sebab dia bersifat positif, dia akan attracted towards negative plate and repel by the positive plate. So the total electrostatic force dia ke bawah. Okay, and then at the same time, this charge has velocity dan ada uniform magnetic field. So dia akan experience magnetic force. So menggunakan right hand palm rule, your fingers here akan point in the direction of velocity, iaitu ke kanan. And then your palm sekarang akan point into the page, iaitu direction of your magnetic field into the page. Dah letak tangan, sekarang kamu tengok thumb kamu akan point upwards of the page. Dia akan point ke atas. Ini adalah kamu punya magnetic force. Okay. If the particles travels in a straight line with a constant velocity v, hence the electric field and magnetic force, hence the electric and magnetic force are equal in magnitude. So, apa yang akan jadi dekat sini adalah your charge here is going to move in a straight line. Okay, dia tidak akan deviate ke atas ataupun ke bawah disebabkan oleh the magnetic force and the electric force adalah equal. FB is equals to FC. Okay, FB kamu sama dengan QVB sin theta because they are perpendicular to each other, sama dengan electric force iaitu QE. You cancel your Q, kamu akan dapat velocity such as electric field over magnetic field. So only particles with the speed equals to E over B can pass through without being deflected. So untuk pastikan charge ini yang tengah initially gerak ke kanan terus bergerak ke kanan di dalam kawasan magnetic dan juga electric field, dia kena mempunyai strength of electric field dan magnetic field punya ratio which is equals to the velocity dia tengah travel. Okay, so kalau dia punya speed ini sama dengan ratio of the electric field to the magnetic field, maka charge kita akan pass through in a straight line successfully without being deflected. Okay. So, untuk case yang ada electric field dan juga magnetic field, dia punya motion ini akan bergerak straight sahaja. Dia tak akan buat any deflection, dia tak akan buat circular motion semua. Dia akan bergerak lurus sebab kita ada magnetic force dan juga electric force yang sama. FB is equals to FE because the forces are the same here. Therefore, the ratio of the field to the ratio of the B will gives you a velocity which is constant. So mereka akan bergerak lurus. Constant dekat sini dia tak akan berubah nilai, dia tidak akan berubah direction. Okay, only when the charged particles entering the region consists of magnetic field only, the particle will make a semicircular path. Okay, ini adalah apa yang kita belajar sebelum ni. Bila kita ada positive charge, dia masuk ke dalam kawasan yang ada magnetic field, dia tengah bergerak lurus, apa yang akan jadi adalah dia akan buat circular motion dekat sini. Alright. Okay, ini yang dia cakap balik. Charged particles entering region consists of magnetic field only. Particles will make a semicircular path of radius r as shown in the figure below. Okay, case ini. Dan kita tahu FB is equals to FC. Kita pernah use this information here. It's just that this time kita nak dapatkan ratio of the charge to the mass, which is equals to electric field divided by the radius multiply with the magnetic field square. So, apa yang jadi dekat sini adalah kita masih samakan FB dengan FC, cuma kita nak tahu ratio of the charge to the mass, E over RB square. Okay, daripada equation yang ini, from this equation, mass spectrometer can be used to determine the value of Q over M for any charged particles. So basically this whole thing kita panggil dia mass spectrometer, di mana it consists of velocity selector dan juga uniform magnetic field. Okay, velocity selector consists of electric field dan juga magnetic field, di mana bila charge itu masuk dia akan bergerak lurus sebab magnetic force sama dengan electric force. Setelah dia bergerak lurus, bila dia dah keluar daripada kawasan velocity selector, dia akan masuk ke area yang hanya ada magnetic field sahaja. Okay, so bila dia masuk ke dalam kawasan yang ada magnetic field, so the B is into the page, the velocity is to the right, using your right hand palm rule, V ke kanan, iaitu fingers kamu pointing to the right, palm kamu into the page, sebab B kamu into the page, kamu akan dapat thumb ke atas, dan kamu punya charge ini akan deflect dan form a semicircular path. Okay, sama jugalah dia boleh buat bulatan, tapi sebab kita ada plate dekat sini, so dia akan stop dekat sini. Okay, so apa tujuan kita letak plate dekat sini dan kita stop dekat sini adalah sebab kita nak tahu this ratio of Q over M. Itu fungsi mass spectrometer, iaitu to determine the value of Q over M. So this whole thing adalah apa yang kita panggil mass spectrometer, di mana kita nak tahu apa dia punya ratio of the charge to the mass in order to identify the charges sebenarnya. Kadang-kadang kita akan ada particles yang masuk yang kita tak tahu pun apa nama particles itu. So we allow them to undergo this process so that we can identify based on the ratio what type of particles are those yang masuk tadi itu. Okay, so kena ingat equation ini, Q over M is equals to E over RB square. Okay, that's it for 4.7.